Hi, everybody. In this lesson, I'm going to go through part two of our lesson on factoring quadratic trinomials. We have already gone through the x factors and how those are used when a is equal to 1 and you do not really have a leading coefficient other than 1. Now we're going to talk about the slip, slide, and divide method for if you have some other leading coefficient. But first, please do not forget when we are factoring, always check for a GCF first. If there is a greatest common factor, you'll want to factor that out first, and then perhaps you'll still be left with some sort of trinomial that you can then use the x factors for, or then you can, factor further. Again, if a is not equal to 1, right, in our quadratic ax squared plus bx plus c, if a is not equal to 1, then we need to slip, slide, and divide. So what are the steps to do this? Just based off of, the name, slip, slide, and divide, it tells you most of the steps that you need to know for this process. So let's write those steps out. So step 1 is going to be to slip. And what this means is you are going to multiply this leading coefficient that we don't want, A. You're going to slip that over to C. So you'll multiply A times C, and now you will be left with some sort of trinomial where A is equal to 1, which is really nice, because then we can slide and we can factor the trinomial using the x factors. Once you have factored that trinomial, then you can divide. And really what this means is you are going to divide the x factors, that you find, by the original A. So whatever your original A value was, you'll divide both of your numbers, your x factors, by that A value. And sometimes there is the opportunity or, the possibility that you could be left with fractions that you can't simplify. In which case you have to do a process that is called bottoms up. And what that means is if I know I have, some x plus maybe 3 over 2, I take the bottom of the fraction, and I'm going to use this purple again, and I pull it up to be with x. So this is like 2x plus 3. I really just multiplied it by 2. Multiplied that factor by 2. That's fine. We don't want to be left with a fraction, so you can do this bottoms up method if you are left with fractions. So let's see how this looks in practice. Number 1, we are going to factor the trinomial 3x squared plus 8x plus 4. So looking at this, I'm going to ask myself first, is there a GCF? And I notice the largest number factor that these have in common would be 1, because 3 is prime. And then the largest number of variables they have in common, none. So no. Now this is a trinomial, right? So this is an ax squared plus bx plus c. It's a quadratic trinomial, and we have an a value. So since a is equal to 1, I'm going to have to slip, slide, and divide. So I'm going to write the trinomial right here, 3x squared plus 8x. Actually, right over just a little bit more. 3x squared plus 8x plus 4. So step 1 is to slip. So we will take our a, this value that we don't really want in front, and I will slip it back to c. So I will multiply a times c, which is really the same thing as 3 times 4. So we'll multiply those two together, and this is now going to give us kind of this new polynomial, x squared plus 8x plus 3 times 4 is 12. Now I'm going to slide into our x factors. So this is a trinomial that I can factor using the x factors. So I'm going to set up my x. We're going to find numbers that are multiplying to c and adding to b. So here's c. The c that we're using is 12, and our b is 8. So I want to find factors of 12 that add to 8. So I'm going to list out my factors of 12. They are 1 and 12, 2 and 4. Oh, I mean 2 and 6. Sorry, I was thinking of 8 for a second. 2 and 6, and then 3 times 4. So which set will add to give me 8? That would be 2 plus 6. 2 plus 6 will give me 8. So our x factors are 2 and 6. So now I will slide this trinomial into its set of factors. We're talking about x here, right? So this is x, and then our x factors are x plus 2 and x plus 6. So we've slipped, right? We slipped a to c to create this new kind of trinomial to work with for now. And then we slid that into new factored forms. And now I have to undo the fact that we slipped, right? I have to divide. So I'm going to divide both of my x factors by the original a, right? The original a, which was 3. So divide 2 by 3 and divide 6 by 3. Now, if I simplify this, I can't divide, right? I can't divide 2 by 3. So this one I will have to do bottoms up. So I'm going to move the bottom of this fraction up with x. So this is really 3x plus 2. And then the second set of parentheses, we can simplify that fraction. So this would be x plus 6 divided by 3, which is 2. So these are the two binomials that I could then remultiply to give me the original trinomial, which was 3x squared plus 8x plus 4. All right, let's look at another example. We are going to factor completely. And this time we are going to factor, let's see which example is it, this one, -2 w to the 4th plus 20 w cubed. Oh, no, not, I knew I picked the wrong one. It felt wrong as soon as I started. It's 5g squared, I'm so sorry. 5g squared plus 9g minus 2. I was switching my second. I'm so sorry. All right, let's factor this. Looking at this, I do not really see a GCF here. And then we have this trinomial, right? This is like some AG squared plus BG plus C. So I'm going to need to slip, slide, and divide. So 5g squared plus 9g minus 2. First step again is going to be to slip our A value from where it is at the front back to C. So I'm going to multiply 5 times -2. So now this is going to be written as g squared plus 9g, and then 5 times -2 is -10. Now I have a trinomial that I can factor, and so I can use the x factors for this. So that my x, we're going to find numbers that are multiplying to c and adding to b. So our c value here again is -10, and then our b value is 9. So I want to find factors of -10 that then add to 9. So factors of -10, we have -1 times 10. I have -2 times 5. And then I have -5 times 2 and -10 times 1. Just the top two, but the other number is negative. Which one will add to give me +9? Looking at the first one where 10, the larger number, in fact, is positive, and adding these, -1 plus 10 gives me 9. So I don't even really need to test any of the other ones. Our x factors here that we will be using are -1 and 10. So now I can factor this trinomial using the x factors. We have g in both of these binomials, and then our x factors are -1 and +10. And then I need to divide, right? We slipped, we've slided. Now I need to divide by our original a value, which is 5. So I'm going to divide both of these x factors by 5. And the second one is the one that will simplify a little bit nicer, right? 10 divided by 5 is 2. So I have g plus 2 times. The second one we can't simplify as nicely, so I need to use that bottoms up method. And I will really write this as 5g minus 1. So here our factored form of this would be 5g minus 1 times g plus 2. One more, and this is the one I accidentally started to write last time. So example 3, factor completely. -2w to the 4th power plus 20w cubed plus 48w squared. So looking at this, this actually isn't even quadratic because the degree or the largest exponent I see here is 4. Let's see here. You know, we always want to look for a GCF first. So let's see if there is one. And when I look at all of these terms trying to see what factors they have in common, I do see they have at least a 2 in common, right? I could remove at least a 2 from all of these. So let's kind of see what else, investigate what else I could remove from all of these terms. And looking at all of these, I see they actually all share a 2, right? I can divide all of these terms by 2. And thinking about really what we want here, this is a trinomial, so it would be cool if it ended up with like w squared. So can I remove 2 w's from each of these? Yes. So I can remove 2w squared from each of these terms. And lastly, notice that there's a negative in front. So that actually is an issue. We can't have this negative in front, so our GCF, we're going to make that negative. So that way the first negative in front goes away. Seems kind of weird. Probably not a greatest common factor anymore, but we're going to factor out a negative as well. So that way we have a trinomial that starts with just w squared. All right, so let's factor this out. What will happen when we factor this out is this -2w squared will come outside, oops, of a set of parentheses. Sorry about that. And then what we get left when we divide, or what, is left over will be inside these parentheses. So negative 2w to the fourth divided by negative 2w squared, the negative 2's will cancel. And then if you have 4w's and you take out 2, you will be left with w squared. You'll be left with 2 of them. Next, 20w cubed divided by negative 2w squared. 20 divided by negative 2 is negative 10. So I will have negative 10 and then 3w's. You take out 2 of them, you will be left with just 1. And finally, 48 divided by negative 2 is going to give us negative 24. Oops. And then w squared divided by w squared, if you have 2 w's, you take out 2 of them, you're left with no w's. So here I now have inside my parentheses a trinomial where a is 1. I have a w squared plus bw plus c. And this I can then factor using or finding my x factors. So I want to find numbers that multiply to c and add to b. And our c here is negative 24. And our b is negative 10. So I want to find factors of negative 24 that add to negative 10. So let's list out factors of negative 24. So negative 1 times 24 will give us a negative. Negative 2 times positive 12. That's interesting to me because negative 2 plus 12 is positive 10. So let's just keep that in mind. I'm going to list out the other factors just in case. Negative 3 times 8, and then negative 4 times 6. And then looking at the opposites of all of these, 1 times negative 24, 2 times negative 12, 3 times negative 8, and 4 times negative 6. And again, I was kind of paying close attention to that negative 2 times 12. Look at 2 plus negative 12. If I take 2 and I add on negative 12, that is going to be a negative, because 12 is way bigger than 2, it'll be negative 10. So our x factors here are 2 and negative 12. So now if I'm going to write out the final factored answer, I can't forget we have this negative 2w squared in front. So my final answer will have negative 2w squared. And then we took this entire polynomial and we're writing it now in factored form. So it'll be negative 2w squared times 2 sets of parentheses. And the variable we're talking about again still is w. And our x factors were positive 2 and negative 12. So if I multiply negative 2w squared times w plus 2, and then I take that and I multiply it to w minus 12, that will give me the original polynomial we began with. Please let me know what questions you have. I know this is a lot and it requires kind of some patience, as you might get some questions wrong here or there, but I'm always here to help.